In this video, we're going to be looking at the area of polygons and circles. And out of this particular video, we're going to be converting units of area. Also, we're going to be looking at land measure, and we're going to be looking at areas of the following geometric figures: a rectangle, a parallelogram, a triangle, a kite, a trapezoid, a regular polygon, a circle, and a sector. We'll first talk about converting metric units of area. Now, if you recall, we were just doing just the regular metric units of length, where you just had kilometer, hectometer, decameter, then the basic unit was the meter, and then decimeter, centimeter, and millimeter. Now, since we're dealing with area, area of course deals with square units. So here, we're going to be dealing with square kilometers, square hectometer, then square decameter, square meter, which is going to be the base unit. And then you have your square decimeters, and then square centimeters, and square millimeters. Okay, now, if you recall, 1 kilometer is always 1,000 meters. 1 square kilometer is now going to be 1 million square meters, because we have 1,000 meters, and if you square 1,000 meters, you're going to have 1 million square meters. Hectometers was 100 meters. Square that, you're going to get 10,000 meters. Decameters was 10 meters. Square that, you're going to get 100. And then the basic unit is your square millimeters. Now, for a decimeter, it was 1/10 of a unit. Now, if you square, you're going to get 1/100th. Centimeter was 1/100th. Square that, you're going to get 1/10,000th. And the millimeter was 1/1000th of a basic unit of meters. So square that, you're going to get 1/1,000,000th of a square meter. Okay, now we're going to use this to convert each of the following. Suppose we want to convert 5 square centimeters to square millimeters. In this case here, we know that 100 square millimeters is equivalent to 1 centimeter. So in this case here, we're going to convert to millimeters to square millimeters, so that's going to be in your numerator. We're converting from square centimeters. That's going to be in the denominator. So here we're going to be multiplying 100 times 5 to get 500 square millimeters. Now, I also like to use this particular conversion table. As well, to convert from meters to centimeters. But here, we're going to be doing square meters here. Now, if you were converting from centimeters to millimeters, here's centimeters and here's millimeters, you would normally move the decimal point one place to the right. But since we're dealing with square units, we have to do 2 times the number of decimal places that we normally move, either to the right or to the left. Okay, so it's 2 times the number of moves to the left or to the right. So here, 1 move to the right times 2 will be 2. So in the number 5, the decimal point's on the end, we'll move the decimal point 2 places to the right. So it'll be 500 square millimeters. Okay, so with square units, when you convert from one square unit of the metric system to another, you're going to have to move the decimal point 2 times the usual number of decimal places if you were dealing with just a basic metric system. And we'll use this to do part B. 1,124,000,000 square meters to square kilometers. Here's square meters right here, and we're going to square kilometers, which is to the left. Now, normally from meters to kilometers, we go over 1, 2, 3 places to the left. However, it's square units, so it's going to be 3 times 2. Well, 2 times the number of moves to the left that we would use if we were doing the regular metric units. So 2 times 3 units, 3 places to the left, would be 6 places to the left. So in the 124 million, we'll move this decimal point 1, 2, 3, 4, 5, 6. 6 places to the left. So the decimal point will be behind the 4. So it'll be 124 square kilometers, which is the equivalent of 124 million square meters. Okay, now we'll look at some English units of area, like the square foot, square yard, and square mile. 1 square foot is 144 square inches. If you recall, 1 foot is equivalent to 12 inches. So if you have 1 square foot, you're going to square the 12. So it's 12 squared, or 12 times 12, which is 144 square inches. Or 1 foot would be 1/9 of a square yard. Because 1 foot is 1/3 of a yard, so square the 1/3. 1/3 times 1/3, that's 1/9 of a square yard. And then 1 square yard is going to be equivalent to 9 feet. Because a yard is equivalent to 3 feet. Square the 3 feet, you're going to get 9 square feet. And 1 square mile is 3,997,600 square yards. 1 mile is 1,760 yards. Square the 1,760 and you'll get the 3,097,600 yards. Or we can say that it's equivalent to 27,878,400 square feet. Because 1 mile is 5,280 feet. Square the 5,280, you're going to get 27,878,400 square feet, which is equivalent to 1 mile. Okay. Next, we'll look at land measure for English units and for the metric unit system. For English units, there are only 2. One of them is the acre, and the other one is square mile. And for the metric units, it's the air, A-R-E. This is pronounced air, like the air that you breathe. Then hectare and square kilometer. And on the next slide, you'll see some of the equivalencies to these other units here. 1 air, which is abbreviated with a lowercase a, 1a, or 1 air, that's the equivalent to 100 square meters. So 100 square meters is going to be 1 air. 1 hectare, which is abbreviated HA, that's going to be equivalent to 100 air, or we can say 10,000 square meters, or 1 square hectometer. And then 1 square kilometer is going to be 1 million square meters, like we talked about with one of the examples. 1 acre is 4,840 yards, and a square mile is 640 acres. So we'll use these to solve some of these problems like this. A square field has a side of 400 meters. Find the area of the field in hectares. In this case here, the area of a square, that's going to be the length of the side, and it's going to be squared. So the length of that side is 400 meters. So if we square the 400 meters, you're going to get 160,000 square meters. Now, we want to convert 160,000 square meters to hectares. Okay, back to this slide here. We know that 10,000 square meters is equivalent to 1 hectare. So in this case here, we're going to take that 160,000 square meters and divide that by 10,000 square meters to come up with our units in hectare, or the measurement in hectares. So 160,000 divided by 10,000 will be 16 hectares. So the square field has an area of 16 hectares. Part B, a square field has a side of 400 yards. Find the area of the field in acres. Okay, so here the length of the side is 400. It's a square field, so that means we're going to square the length of the side. 400 yards, and we squared will be 160,000 square yards. Okay, now back to the other slide, you're going to find that 4,840 yards is equal to 1 acre. Okay, so we're converting this from square yards to acres, so we take the 160,000, divide that by 4,840 acres. Well, square yards to come up with our unit in acres. So here, 160,000 divided by 4,840 is going to be approximately 33.1 acres. So the area of that field is approximately 33.1 acres. Okay, now we'll look at some of the areas of these geometric figures here, or two-dimensional figures, as I should say. The area of a rectangle. Okay, each rectangle has a length and a width. So to find the area, we just simply multiply length times width. So if this length is 4 and this width is 3, we multiply 4 times 3, you're going to get 12 square units. So the area of that rectangle will be 12 square units. Now, had it said square inches, then had it said inches here and here, then you'll say square inches, 12 square inches for the area. But the units are not given, so we just say 12 square units. All right, next is the area of a parallelogram. The parallelogram has a base and a height. So this is the base going straight across, and the height goes straight up and down. Keep in mind, the base and the height are always perpendicular to each other. You can tell by this box right here. This has to be the base, this must be the height. So the area of that parallelogram would just be base times height. Now if you were using the A for your base and the G for your height, then it will be A times G, because A is the base, G is the height. Keep in mind the base and the height are always perpendicular to each other in this two-dimensional figure. Okay. Next is the area of a triangle. Now in an area of a triangle, that's going to be 1/2. A triangle is going to be 1/2 of a parallelogram. So here you have a parallelogram like this. If you draw through the diagonal and just take out this part right here, then you will have a triangle, which is 1/2 of a parallelogram. And of course, the area of a parallelogram is going to be the base multiplied by the height. But since we have a triangle, it's half that. So it'll be 1/2 the base times the height. Because the triangle is 1/2 the area of a parallelogram. Okay, now let's look at a couple of these examples here. Let's say we want to find the areas of each one of these. The one on the left. Here, this is going to be your height, and it's always perpendicular to the base. Now keep in mind, sometimes they may give you additional units to throw you off, but keep in mind, the base and the height are always perpendicular to each other. So those are the units you want to use. Here the base is 5 and the height is 8. And it is a parallelogram, so the area of the parallelogram is always going to be the base times height. So here the base is 5 and the height is 8. So you're just going to multiply 8 times 5 to get 40. And notice you have to put the square unit still that's given to you. So it's going to be 40 square centimeters. Okay? And that's very important that you put these units here and not just the number itself. Because you want to specify that the area is going to be in square units. So here's given centimeters, so we say 40 square centimeters. Alright, this one, we have a triangle here where the base is 10 and the height is 4. In a triangle, the area is always 1/2 the base times the height. So in this case here, we're going to be taking 1/2 the base, which is 10, and the height, which is 4. So in this case here, if you take 1/2 of 10, you're going to get 5. 5 times 4 is 20. So the area of that triangle is going to be 20 square centimeters. And for the one on the bottom, now notice that the height is on the outside of that triangle. That height is 4. Here, the 2 centimeters where you have side AB, where this side has been extended, that will be your base. So the base is 2 and the height is 4. So you're going to have, again, the area being 1/2 the base times the height, which means you're going to have 1/2 times the base, which is 2, the height is 4. So if you take 1/2 of 2, it's going to be 1. 1 times 4 is 4. And it'll be 4 square centimeters. So the area of that triangle will be 4 square centimeters. Okay. So that's how we compute the areas of the parallelogram and of the triangle. Alright, next is the area of a kite. Now the area of a kite can be found by relating this to the area of the rectangle. So let's say we have a kite right here. Of course, we talked about what a kite was in one of the videos here. A kite is nothing but a quadrilateral where you have a pair of two adjacent sides that are congruent. That means this side and this side are congruent, and then these two adjacent sides are also congruent to each other. Here, this diagonal here, that's diagonal number 1. This diagonal going up and down is diagonal number 2. If you were to rearrange or cut out these 4 triangles and rearrange them, it'll end up like this, where this length is the diagonal here, and this height or this width is going to be 1/2 the second diagonal. So here the area is going to be 1/2 the product of the 2 diagonals. Area is equal to the area of the first diagonal times, well, the length of the first diagonal times the length of the second diagonal. So in this case here, let's say that the length of this first diagonal, I'm going to say the length of that first diagonal was 14. So here, D1, that's 14, and D2, that's the length of this diagonal here. Let's say that's, I'm going to say 6. I'm just making up some numbers here. And here I want to find the area of that kite. So here the area is going to be 1/2 the first diagonal, which is 14, times the second diagonal, which is 6. So in this case, if you take half of 14, that's going to give you 7. 7 times 6 is 42. So it'll be 42 square units. That's the area of that particular kite here. If the length of the diagonal was 14 and the length of the second diagonal was 6. So it'll be 42 square units for the area. That's how you'll compute the area of a kite. Okay, the next figure is a trapezoid. Of course, the trapezoid is a quadrilateral with with at least one pair of parallel sides. And those parallel sides are going to be the base. Your height is always perpendicular to your two bases. So in this case here, the area of that trapezoid will be 1/2 the sum of these two bases times the height. And they have 1/2 the height multiplied by the sum of the two bases, B1 and B2. And here's an example of this one. Okay, now I'm only going to look at just this one right here. Here I want to find the area of this trapezoid. Here I'm given a height of 4 centimeters. My two bases are given 12 centimeters and 16 centimeters. So in this case here, we're going to find the area using this formula, 1/2 the height times the sum of the two bases, B1 and B2. So I have 1/2 times the height. In this case, the height is 4 centimeters, times B1, which is 12. I'm letting B1 be 12, and B2 be 16. Okay. Now you can let the 16 be B1 and the 12 centimeters be B2, but either way, you're going to have to add those two together, the sum of those two bases. Now, if I take half of 4, that's going to give me 2. Add 12 and 16 together, you're going to get 28. 28 times 2 is 56. So it'll be 56 square centimeters. That's the area of that particular trapezoid. Okay. So that's how we use that formula to compute the area of a trapezoid. All right, the next is the area of a regular polygon. If you recall, the regular polygon is a polygon that has the lengths of all the sides congruent and all the angles in that regular polygon are going to be equal. Okay? So in this case here, we do have a formula for that, which is going to be 1/2 A times P. And I do need to explain what those letters mean. The A has a special name. It's called the apothem, which is this length right here. It's actually the length from the center of the circle and is perpendicular to a side of that regular polygon. That's what the apothem is. In other words, it's the vertical height of this regular polygon. Starts from the center of that polygon and is perpendicular to the side of that particular regular polygon. The P is the perimeter of that polygon. And in this case, the perimeter, if you recall, is always going to be the length of the side times the number of sides that you have in that regular polygon. That's where this n times s comes from. N is the number of sides of that polygon. S is the length of that side. So if you take the number of sides times the length of each of those sides, you're going to get the perimeter. Okay, so that's what these letters stand for. The apothem is always going to be the vertical height that starts from the center and is going to be perpendicular to a side of that regular polygon. And of course, the perimeter is just the number of sides times the length of that side itself. And before I move on, let me do an example of just one. Let's say we had a regular here's a regular hexagon, and here this length, which is your apothem, is 2 square root of 3. And the length of this side is 4 centimeters. And I want to find the area of that regular hexagon. Here all the sides are equal, including this one. Okay. First of all, I know what the apothem is, which is the A. That's this length right here from the center of the polygon to a side perpendicular to it. And that's 2 square root of 3. Now to find out what the perimeter is, the length of the side is 4 centimeters. And I have 6 equal sides of 4 centimeters. So that's going to be 6 times 4, which is 24 centimeters. And by the way, that 2 square root of 3 is also in centimeters as well, I should say. So now the area is 1/2 A times P. Okay, now if I simplify this, well, just replace the A and the P with those values. A is 2 square root of 3, and the P is 24. So in this case here, if I take 1/2 2 square root of 3, well, 1/2 of 2 is 1, so I'm left with the square root of 3 times 24, and I'll just leave this as 24 square root of 3, and that's going to be in square centimeters because the area is always in square units. So the area here will be 24 square root of 3 square centimeters as the answer. Okay. So that's how we use that particular formula to find the area of any regular hexagon or any regular polygon. Now the area of a circle. Should be familiar with this one because the area of a circle is always going to be pi times the radius squared. The radius is always from the center of the circle to a point on the circle. So if the diameter is given, which is going to be is that length from one point on the circle going through the center to another point on that circle, you have to take half the diameter to get the radius, and then use that formula. So let's say the radius was 5 centimeters. And we want to find the area of that circle. The radius is 5 centimeters, and we want to find the area of the circle, which is, of course, pi times the radius squared. And let's say we want to leave our answer in terms of pi. So the radius is 5, so that's 5 centimeters, and that's going to be squared. Well, if you square 5, you're going to get 25, and we're going to bring down the pi. And this is going to be in square centimeters. So here the area of that circle will be 25 pi square centimeters. Now if they tell you to use 3.14 for pi, then you'll do 25 times 3.14. And you'll get your answer in square centimeters. Okay, so that's how we use the formula for the area of a circle. Okay, last is the area of a sector. A sector is nothing but a piece of the circle, and it's this shaded area here. That's the area. That's going to be the angle measure, which is called theta. That's the angle measure divided by 360 degrees, because in an entire circle, the measure of the entire circle is 360 degrees multiplied by pi r squared, because we're taking a portion of the entire area of the circle. That's the pi r squared, that's the area of the entire circle. But here we're taking a piece of that, so that piece is going to be the theta, the angle measure, divided by 360 degrees. So let's say this had a radius of 4, and the angle measure, which I'm calling theta, that's 60 degrees. And I want to find the area of that sector with a radius of 4 and 60 degrees as your angle measure. Okay, so in this case here we'll say A is equal to theta, that's 60 degrees, over 360, multiplied by pi times the radius, which is 4. Let's say this is 4 centimeters, by the way. 4 centimeters, and that's squared. Okay, now let's simplify this a bit. I can reduce 60 over 360 to 1/6 times 4 squared is 16. So that's 16, bring over the pi, and this is going to be square centimeters. So here, this is going to be 16 over 6, because from 1/6 times 16 over 1, that's going to be 16 over 6 pi square centimeters. And if I reduce this in simplest form, 16 over 6 will be 8/3. So it'll be 8/3 pi square centimeters. That's going to be the area of that particular sector with a radius of 4, and the angle measure is 60 degrees. Okay, so that will conclude this particular video on the areas of polygons and circles.